I'm so happy you're here today because I'm going to tell you a very special story from the pages of the history of life. The story is called The Evolution of Movement. To start, let's pretend you're a paleontologist, which means you study fossils, and that's awesome. And while we're pretending, let's pretend I'm a time-traveling wizard, which is great because it means I can take you back in time to study the animals you study as fossils today. So why waste any time? Let's get into my magical time machine. Back to the Jurassic period of geologic time. Zwing! Over 150 million years ago. Step out, and what do we see? Well, dinosaurs, of course, they're everywhere. Look, a fearsome ceratosaurus barreling towards its prey. And over there, a massive stegosaurus lumbering through the forest. And holy Toledo, a 30-ton apatosaurus reaching high for some leaves. All these dinosaurs moving. But is this the first time animals moved? No. Life spans the past 3.5 billion years of the Earth's history. We're going to have to go way back to see the first animal movement. So back into the time machine. Zwing! An additional 400 million years into the past. Step out. And where are we? We're in the Ediacaran period of geologic time. There are no land plants, no land animals, but if we swim out beneath the waves, we see a spectacular scene, a garden of alien-like life forms that we can see with our eyes. For the first 3 billion years of the history of life, life was microscopic. You couldn't see it, but now we can see things with the naked eye. Everything that we see at first glance is stationary. Nothing is moving. But wait, what's that? There's a tiny little worm moving through the sand, pushing aside sand grains that are almost as big as he is. This is the evolution of movement. While small, this worm couldn't have bigger implications for all life that came after it. And that's because this worm is a bilaterian. A bilaterian is an animal with bilateral symmetry up and down the midline, as well as a through-going gut, like you, me, dinosaurs, cats, dogs. What bilaterians also have is a body cavity. And this is the key feature that's enabling this worm to move through the sediment. So really, this little worm is all us bilaterians in one. What was it doing there in the sand? Well, it was probably looking for food, the same thing you and I do every day. So when you move out of your chair, when you move across the room, move to grab that sandwich, remember this little worm taking one giant wiggle for all animal kind.